Okay, we're in 96. Again, very consistent story being told. There's contents for you to look at. There's examples for you to work on, and then exercises for you to do. The exercises are related to the contents and examples, and we hope you can follow that. It is tough, though. I know that. So my name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra. This document, the PDF that you're looking at, is being made available to the Prison Mathematics Project participants only. I realize there may be students and teachers looking at these videos, and they're interested in getting a copy of my version or my adaptation of Webster Wells' Advanced Course in Algebra. And if you're interested in that, just email me and I'll let you know when it's going to be published. It's not published yet, but my email address is B as in boy, the @ symbol, NNON.US. All right? So I'm going to say, we're moving along, and someone says, what's this all about? It's about logs, and I know logs are important. At least historically, they're important in computation. For us, they're not so important for computation. We have calculators to do that. So I just want to make sure you know that we have some basic rules that we've covered in the last section that we're going to continue to use. And those rules are really nice to have, by the way. All right, so I'm looking at this over here, and they give me something. And they gave me this. Oops, sorry about that. I know I do it a lot. They did it again. They gave me this, but they want this. So I got to wonder how what they want, is related to what they give me. And let me write this down over here. So it looks like log. I'll write this down. I'm going to write, it looks like 3.053 times 100. So now I think I see it. And what's that going to be? A product now, right? So I'm going to write the sum down. Log 3.053 plus log, these are base 10 logs, by the way. Now again, I hope you're getting better at this. Maybe not. Let me write this over here. Log base 10 of 100 equals some number. Well, if you thought about it, 100 would equal 10 to the x. X has to be 2. Let me write that down. That would be plus 2. And what's the log of, whoops, I'm using a symbol I shouldn't use. This is not going to be equal. It's going to be approximately equal. What's it approximately equal to? Well, approximately equal to the log of 3.053, which is approximately 0.4847. And if you add that together, you get this over here. All right, let me do the next one. It looks like it might be related. So I'll write this one down. This is the given. This is what the want is. So let's put this over here. This is log, and that's going to be 0.03053. So what I got to do is I got to write it so it has this number in it, and some power of 10, by the way. And why is that? 10s are easy to deal with. So let's write that down. It looks like, I don't know, it looks like this, 3.053. And if I look at that, the decimal have to move 2 places, so it'll be 100. Let me make sure that's right. So 2, yeah, that looks good. So what do you get over here? This is log. This is equal, by the way. When I mean, it's equal to my work, by the way, not that over there. Log 3.053 minus log of 100. Well, we just did log of 100, right? Now, certainly, I want to make sure you know this is an approximate answer. And why is that? Well, the log of 3.053 is approximately 0.4847. And the log of 100 we just did is 2. All right? The arithmetic is written over here for you. All right? I'm just interested in writing things down. So I'm going to say over here, there's something given to me. Now, certainly, someone says, why do they give me these things? Well, when you're given something, they have a want. And I'm looking at this and I'm wondering, how could I get that? Right? How could I get that? And I got to look at it. And I'm looking at it. And I'm just seeing a 2 and a 3. Well, you know what? I don't know. I don't know how I'm going to get it. But I'm going to write this over here. I like integers. So I'm going to write log. And I bet when I write integers down, I'm going to see the 2 and the 3 and some power of 10. So what do you get? 432 divided by what? Let me count the decimal places for you. 1, 2, 3, 4, 5. So it's going to be 10 followed by, 1 followed by 5 zeros. That's a lot of zeros. Let's write this down. So this will be equal to log 432 minus the log, and let me just count that up. What's going to be, it's 10 to the 5th power, right? Write this over here. And maybe I'm getting better at this. I don't know. Let me put 432 down. I'm hoping the 432 is related to 2s and 3s. 2, 2, 16. 2, 108. 2, 54. 2, 27. I'm done with the 2s. 3, 9. 3, 3. So I'm going to write this as log, let's see, there's 1, 2, 3, 4 2s, 2 to the 4, plus log, I know it's a product by the way, so I'm putting plus down, 3 cubed, minus log 10 to the 5. Well, I'm going to say this is 4 log 2 plus 3 log 3 minus, I think I'm ready to do this over here. That would be 5 times log 10 of 10, which is just simply 5. All right, let's do this over here. It's approximately 4 log of 2, it's written over here, 0.3010 plus 3 times the log of 3, that's written over there, 0.4771 minus 5. I want to point out that stuff's written over here for you. Again, I'm not interested in doing arithmetic, but you can do it if you want. 4 times 0.3010, 3 times the 0.4771 minus 5, all right? Let's keep going. Oh, there's no more to do, which is good news. So what I got over here, let me point out what I mean by this. You're going to be doing the exercises. I hope what you've read and what we just did in the examples will give you some indication how we do these problems over here. Be aware that I'm using these symbols over here. Wells does not use those symbols. Or these symbols, they're saying it's approximately true. If I were doing this problem, though, I'll be honest with you, I don't think I would do this method. But there is a point here that historically this is what was done. You had to do this, by the way. And there were limited tables. They didn't have a bunch of numbers in them. Now we have digital computers that do logs very simple, all right? And logs are an important concept. And we use them in mathematics, just not for arithmetic anymore, all right? So we'll get to that arithmetic part soon, by the way. All right, you got the Sage business. Oh, before I do that, I want to point out, you got about 8 problems there, and it's manageable. It wasn't that bad, all right? And then you got this, log business over here with Sage doing logs. Sage can do any base, by the way. And what do you mean with that? Base 2, base 10, base 7, base 6, base E, whatever, all right? So I want to point out, though, in most upper-level mathematics courses, that LOG does not mean base 10. But I wouldn't worry about that. You're not at that level yet. You're at the level where LOG always means base 10. I got to be honest with you. I would prefer that if people wrote log down, they would specify the base, whatever it is. Right? We shouldn't assume that's base 10 just because it's always base 10, because it's going to change, and that's a misfortune. But anyway, don't worry about that now. If you're confused, ask your teachers. Okay, what am I going to do over here? If you're looking at my work and you think there's an error, please reach out to me. My name is Bannon. My email address is B as in boy, the @ symbol, nnon.us. Real quick, Sage, computer, algebra, system, open source, website, downloaded, or interactive web-based application, and try to type in some of the code, see what happens. All right? Thank you for paying attention.